Welcome to the viewers. Now I discuss today that how an ball, that is open ball, formed in metric space, and this is a very much effective tools and needed in many cases of metric spaces. At first, let's define open ball. If we denoted BR of x0, that signifies where, if we given that R is the radius and x0 is the center, and how to define it. Actually, BR x0, that is given as if any element, say x, if belonging to the spaces and distance function metric, that is this distance x0 to x is less than r, that is open, and which is the subset of x. That means if x is a space, entire space, where any metric is defined d, and if we find that this type of radius here, that is x0 be any point, and here is the total r, that is the radius, and if we find any point here, suppose x, just outside the boundary, just inside the boundary, sorry, and we define it as these things, and this is a proper subset of r because x is defined here and any kind of metric d is defined. By these definitions, we declared is an open ball because this is the interior point, that's why, and which is centered at x0, which centered at x0, having radius r. This is the way. And if we consider this type of open ball, now if we consider a closed ball, what happens there? Just simply, if we consider a closed ball, then and obviously it is an open ball, concept of an open ball in a metric space. If we consider a closed ball, then we consider the subset just simply one changes if x belonging to capital X such that this metric d centered at x0 to x, that is less than equals to r. Only one change is less than equals to r, and this subset of x is called a closed ball having center at x0 with radius r. This is called closed ball. And the subset of the sphere, if we call the subset that is x belongs to capital X, d of x0 to r, x is equal to r, then it is of x is called a sphere that centered at x0 having radius r. Simple things. That is equals to just maintaining these conditions. In this way, it is also called boundary or BDR if we define it as any point x belongs to capital X such that metric of x0 to x that is equals to r, and which is the subset of x. That means here is the point and x metric spaces centered at x0 and total r is the radius and x be the points and boundary. This point x and boundary, that's why it's a boundary. And in this way we define the boundary points and of open ball or closed ball, BR of x0. And the center of the sphere obviously is not the member of the sphere. It should be noted here that the center of the sphere is not member of sphere. So in this way we describe this idea of open ball system and closed ball system in metric spaces. It's very much useful to study for the study of metric spaces. In many cases we use these ideas. We end our discussions here. If you like this video, like it, share it, don't forget to subscribe the channel. Thanks for watching.